Welcome back. Today we'll be solving a problem called container with most water in Swift language. Let's read through the problem. You're given an integer array height of length n. There are n vertical lines drawn. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Slant means to tilt, so you cannot tilt the container. Let's look at the example. So as an input, we have an array of integers here, 1, 8, etc. So 1 corresponds to the first small line, 8, it's a longer line, etc. And our goal is to find the amount of water that we can store between some of these two lines. So we need to find the maximum amount of water we can store. So the first question is how to actually calculate the amount of water between two lines. You can see that we have here a container, a rectangle, and to calculate the amount of water, we just need to multiply the one side by another, so the height by width, and height here would be just the height of the smallest line. So you can see that we have two lines that are forming the container, and we are taking the smallest one. And for width, we would just take the difference between the index of the second line minus the first line. So we can calculate the amount of water. How to actually solve this problem? So the brute force here would be to try all possible lines. So we would have two for cycles, and we would just go and try each combination of lines and calculate the amount of water between them and just update the variable called max amount of water. So this solution would take, so O of n would be n squared. So it's for a brute force solution, it's not that good. And I think there is a better solution. So a better solution would be to use a two-pointer approach. So we would have two pointers, let's say like left pointer and right pointer. Left would start on the left and right on the right. And we would calculate the amount of water between two pointers, left and right, and then we would move one of them. We would move the one that is smaller. So let's say we would start from here. So left would be here and right would be here. So we can see that we would calculate the amount of water. So it would be this rectangle. And we can see that there's not that much water. And then we would move the left pointer because it's smaller than the right. And actually on the next step, we would have left here, right here. We would calculate this amount of water, and then we would move the right pointer because right is smaller than the left. So right would be here and etc. until the pointers would meet in the middle. So in this way, we don't need to go through every line multiple times. So we would do this only once. So the complexity, the time complexity here would be linear, and I think it's a better solution. Let's code it. All right, so we have a function max area and input height. First, let's do a guard statement. Guard height count more than 1, else return 0. Then we would write our left pointer, which is equals to 0, right pointer equals to the last element of our array, and max amount initially is 0. Then we have our while loop. We would implement it while left is less than right. So the water amount is right minus left multiplied by minimum height of left and right lines. So we would calculate water amount on each step of our while loop. And max amount, so we would update our max amount variable, water amount, and also we need to update our pointers for each step. So if height of left would be less or equals to height of right, then we would move our left pointer to the left +1, and otherwise we would move our right pointer right -1. So left pointer would be going to the right and right would be going to the left, and return max amount. Let's run it. Okay, so all good. You can see that both test cases are working. Let's submit our solution. Amazing. Works really good.